Okay, we're going to do H9F, Affine matrix transformations and translations, and composite transformations. That's a mouthful. Okay, so we've been working with linear transformations all along. And so if I've got a transformation that I multiply to a matrix, we simply multiply our transformation times the matrix. Um, so and a composite is when we have one transformation and then another transformation all happening one right after the other. So if a second transformation is performed, then we're going to be writing it like this. So, for example, if the second transformation happens, we write the second transformation before we write the first transformation. So when we're going to be doing this operation, we're going to be multiplying our first transformation times our image matrix, and then after we've multiplied the first transformation times the image matrix, we multiply the second transformation times the image matrix. And we'll be doing some of that during this video. So find the transformation of matrix A and matrix B, reflection on y equals x. I'm going to just flip this over for a second. If I've got the point 1, 0 and 0, 1, okay, and if I put them in this order, 1, 0 looks like that, and 0, 1 looks like that. And we use these two specific points when dealing with transformations, because if I use these specific points, this is an identity matrix, right? And we've learned that we can multiply things times identities. So in this example here, we wanted to reflect on the line y equals x. Okay, I'm going to call this point A and point B. Okay, so if we're going to do a transformation on the line y equals x, that means we want this point here to go to there. So the new A prime is going to be 0, 1. And then this one's going to go over here, because if it's reflecting over here, this new B prime is going to be 1, 0. So my new B prime is 1, 0, and the new A prime is 0, 1. So this is my transformation matrix. Matrix for the line for the reflection on y equals x. Now, most of our transformation matrices are on our formula sheet, but that one in particular is not on here. So I wanted to show you how easy it was to actually figure out what the transformation would be. So matrix A is a reflection on y equals x, so here's matrix A. Matrix B is a transformation matrix, anti-clockwise rotation of pi over 3. So anti-clockwise, counterclockwise, we're going to be using cosine theta, sine theta, negative sine theta, cosine theta. So I'm putting in, instead of theta, I'm putting in pi over 3, just as I've done here. And then if I type cosine pi over 3 into my calculator, I get 1/2. And if I do sine pi over 3, we get radical 3 over 2. Now, I guess I didn't get radical 3 over 2 from my calculator, did I? We could have also gotten that from our unit circle. Pi over 3, the cosine value is 1/2, sine value is radical 3 over 2. Okay. So, um, so determine the nature. So if I want to do matrix B first and then matrix A, I put them in this order and I multiply it. So I do 0 times 1/2 plus 1 times radical 3 over 2 to give me this value here. To get this one here, the second one here, I do 0 times negative radical 3 over 2 plus 1 times 1/2, and that's how I get 1/2. To get this value here, I do this row times this column. 1 times 1/2 plus 0 times radical 3 over 2, and so on. And this is the matrix we get for that. Now, if I do matrix A first, which is this, and then matrix B, well, if I do, for this value here, it's 1/2 times 0 plus negative radical 3 over 2 times 1. And you can see that these are different. This is radical 3 over 2, this is negative radical 3 over 2. These values here are not the same. So what we've basically learned, and we already knew this before, if I've got two matrices that I multiply by each other, switching the order of them they're not equal. So the corresponding linear matrices are different. Okay. So find a single linear matrix for the equivalent. So if we want a reflection on the x-axis followed by a counterclockwise rotation of pi over 2. So a reflection on the x-axis, if that's happening first, this is a reflection on the x-axis is 1, 0, 0, 1, and a counterclockwise rotation of pi over 2 is this matrix here. So so I have to put them in this order. If this is happening first and this is happening second. When I multiply these two matrices together, we get this. Okay, and we know from over here, this is a reflection on the y equals x. Okay, I'm going to skip 2b and maybe have a video on that one a little later. And same thing with 2d. I'll have a video on that one later. So find the single transformation if I have a reflection on the line y equals radical 3x followed by a reflection on the y-axis. So a reflection on the line y equals radical 3x, when I have a reflection on a line, we're going to be using this transformation. And when tangent theta equals radical 3, we can look here and we can say, okay, if I have tangent is sine divided by cosine, radical 3 is going to be, to get radical 3, we can do radical 3 over 2 divided by radical 2. So if tangent theta is radical 3, then we know we're going to be at 60 degrees, or pi over 3. Okay, so if I'm going to be at 60 degrees, then using this transformation for a reflection line, I'm going to be plugging 60 degrees in for the angle here. So that's how I get cosine 120, sine 120, sine 120, negative cosine 120. Okay. And then a reflection on the y-axis is this matrix here. Okay, so when I multiply this matrix times this matrix, I'm going to end up getting this, and then it simplifies to this. Okay. Now, when we have an affine transformation, we've got our transformation that happens. This is our transformation. And this is our translation. Translation's a little different. It's just moving left and right, up and down. There's no twirling, there's no making bigger or stretching. It's just moving it left and right. So um, so you can read this example, which was given to you here. But we've got, in this example, we've got a point 3, 2, which undergoes a translation of this. So basically, if it's doing a translation, we're just adding we're just adding this value to my original point to get our new point. Okay, so so write down the matrix equation of reflection on this line. So I had to use my calculator. So for this is the equation of a line reflection. So I need to figure out, we know that tangent theta equals 1/2. So then I can do inverse I can do inverse of this tangent, sorry, inverse tan of 1/2, and then I get this value here. Okay. So then if I multiply 2 times this, and then do cosine of that angle, sine of that, then this simplifies to this, and then we also have our translation of 3 and -1. So I have written it in this format here. Okay, an anti-clockwise rotation through pi/6, followed by a translation here. So in anti-clockwise rotation, we're going to be using this relationship, and we're going to be putting in pi/6 in place of theta. And then I can use my calculator or my units. Well, using this way, I would be using my unit circle to get these values here. Okay, horizontal stretch, scale factor of 1/3. So I go over here, horizontal stretch. I'm going to be doing this, and instead of k, I'm going to be having 1/3. Okay, there's my affine transformation. Okay, now this is an example in your Oxford book. We've got a square with these coordinates, and it undergoes this transformation and this translation. So by multiplying the two transformations, show that this is going to be the transformation when we use an enlargement scale factor of 0.5 followed by a reflection on the y-axis. So an enlargement scale of 0.5, enlargement means we have k here and k here. Instead of k, we're going to put 0.5, okay, followed by the reflection of the y-axis. So that's going to go here in order for it to be followed by. I know it seems like it should be switched, but the first thing that happens has to go here on the right. The second thing happens has to come first. Okay, reflection on the y-axis. Let's think of it this way. Okay, so if I'm reflecting on the y-axis, that means this point here um, 1, 0. If we're reflecting on this line here, this is going to stay the same, 1, 0. And this one here is going to go down here. So instead of being 0, 1, this is going to be 0, -1. So 0, -1. So this is reflecting on the translation, reflecting on the y-axis. So is that what I just did? Oh, that was reflecting on the x-axis, wasn't it? Oops. Okay, reflecting on the y-axis is when, here's the y-axis, so that point's going to stay the same. And this one here, 1, 0, is going to switch over to here. So our first point, 1, 0, is now going to become negative 1, 0. And the second value is going to stay the same, 0, 1. Okay. And then we multiply this across, and we get our transformation that has both of those things happening. Okay, determine the coordinates and the vertices of the new image. So I'm multiplying my transformation matrix times my new coordinates. So negative 2, 4, negative 6, negative 3, 1, negative 7, here, 5, 0, there. So each of these columns represents one of these 4 points. And then if I do my transformation of this times this, I end up with this. And then we also have the translation of 3, 2. So I have to add 3, 2 to each column here, and we end up with our new points. You might want to hit pause. If I plot those new points, it's going to look here. And so you can see that it's been enlarged by a scale factor of 1/2, or it's been shrunk 1/2, and it's also been reflected on the y-axis. Okay. So we've got the points A, B, C, and D, and I've written those points here, A, B, C, D, and we've got this translation that's happening. Okay. And so when I multiply this transformation, if I multiply this transformation times my original image, I end up getting this image. And then if I add our translation, the 6, negative 2, to each column, I end up with my new coordinates here. Okay, the coordinates of point that has an image of this. Okay, so we've got our transformation here. The coordinates of the point whose image is this. So they're saying the final result is this. Okay, so negative 6, negative 3 is our final result. It's the final image of, and we want to find the coordinates of the original point. We're trying to find the coordinates of the original point. I'm going to call the original point x and y. Okay, so we're going to apply this transformation, and then we've got the this here. So what we do here is we need to subtract the 6, 2 on both sides in order to make this part go away. So I do negative 6. I have to subtract 6 on both sides to get rid of this 6, and I have to add 2 on both sides to get rid of this 2. And now x prime y prime becomes this. Okay, the negative 12, negative 1. So I had to subtract this and put it over here in order to do that. And then now I can find x and y if I have the inverse matrix of this times negative 12, negative 1. So I take the inverse of this times this matrix, and I get this. And I entered that into my calculator. Okay. And just as a reminder of what we did here, so in order, um, this is transformation. Okay, I don't know what I'm saying. Okay, so question 2. Under the transformation image, under the transformation T, the image is x prime, y prime of a point is obtained by a matrix equation this. So our transformation is this. Okay, so here's our transformation. Find the image of the point negative 5, 8. So if this is my image and I've got my transformation, we go through the process and we get our image. Okay, the point with an image of 3, 6. So my result is this. We need to find x, so I have to take the inverse of this matrix times the 3, 6, and we get this. Okay, I'll show you. Alright, let me just... Here, I'm just going to zoom in on each of these so you can see it better. Hit pause. I'll move this over here. You can hit pause. Okay, so we have a transformation, first enlargement by a scale factor of 3, and then by a rotation of 90 degrees counterclockwise. Determine the 2 by 2 matrix. Okay, so here we've got our 2 transformations and then our translation here. So I need to multiply these 2 together to get a single transformation. That's the 0, negative 3, 3, 0, x plus our translation. Okay. Question B. We want to find a second image. Determine the image now by rotating 180 degrees around the origin, and so this thing in yellow, the 0, negative 3, 3, 0, x, y, plus 2, 3, that was our result from what we had here. Okay, and so now I'm going to multiply that times this, which is the transformation from rotating 180 degrees. When I rotate 180 degrees, the transformation is going to be negative 1, 0, 0, negative 1. Okay, I'm going to zoom out so you can see everything here. So when I've got this, I'm going to multiply this transformation 1, 0, 0, 1 times this guy here. And I get this. And then I'm going to multiply negative 1, 0, negative 1, 0 times the 2 and 3, and I get this. And 0, 3, negative, so the 0, negative 3, 3, 0 has become 0, positive 3, negative 3, 0, because I had multiplied these two together to get this. And then the negative 1, 0, 0, negative 1 has been multiplied by the 2, 3, and then that gets me this. So this should not have been highlighted in pink. I'm sorry. I wish I had whiteout. Okay, this is your final answer though. Okay, and then so our A value here is 0, 3, negative 3, 0. Our C value here is negative 2, negative 3. Okay, almost done here. Well, kind of. Okay, so find the matrix transformation for P, Q, R, and S. Okay, represents reflection on the x-axis. So if I'm reflecting on the x-axis, this is going to stay the same, 1, 0, and this value here is going to go down to here, and now this value here is going to now become 0, comma, negative 1, and so that's where this 0, negative 1 comes from. Okay, matrix Q represents clockwise rotation of 135. So clockwise rotation, right here, I'm going to use cosine theta, sine theta, plug that in here, but I put 135 in there, and we get these values. Okay. Reflection on y equals radical 3x. I think we saw this earlier in an earlier example. And S represents a stretching factor of 2 parallel to x and a stretching factor of 4 parallel to y. So using these values here, k for horizontal, I'm going to change to 2, and k for vertical, I'm going to change to 4. Okay? And so now I'm going to do find a single matrix that transforms Q followed by P followed by R followed by S. So if Q is first, it's going to go right here. P is next, it's going to go right there. R is next, it's going to go right there. And S followed by S, that's the last thing, so it's going to be first. I started doing this by hand, and I was like, no, this is just crazy. And so I put it all in the calculator. Let's see if I still have it in my calculator. Okay, this is P, I believe. Okay, that's Q. Oh. Okay, C is R. Okay, so what I did on my calculator is I have on my calculator matrix A is this one here, matrix B is this one here, matrix C is R, and matrix D is S. So what I did here on my calculator is this first one here is matrix D. And then R, which is matrix C. And then P, which is matrix A. And then Q, which is matrix B. And I hit enter, and then I got these values here. Okay, and then find a single transformation in this form when this is translated by a vector 4, negative 2, followed by R. So we've got our transformation. So we've got this translation of 4, negative 2, and then followed by R. So this is going to happen next. Followed by R means this blue thing is going to happen second. So what's happening here is I need to multiply this blue matrix times xy plus this blue matrix times 4, negative 2. I hope that helps, and there you go.